Good morning, it's me, Mr. Truman again, back for another lesson in geometry. Today we're going to be looking at something called inequalities in two triangles. And what we're going to be doing today is we're going to be looking at two triangles that have a few things in common, and we're going to use the angles or the sides, the third side, to figure out how they compare to each other. I'm going to be using something called the hinge theorem, which I had to save some board space so I didn't write it all out, but I'll try to make this as short and sweet as I can when it comes to explaining it. But the hinge theorem says that if you got two, for example, triangles that have congruent sides, two sets of congruent sides, then the third side that they have on each triangle will be determined, the length of that can be determined by the angle of the hinge. So if you will, look at this one here, and we'll call this the hinge or the angle. You can see that in this one, we have a longer distance between A and C than we do on X and Z. And that's because the angle or the hinge on this one is larger than the hinge on this one. You can see that the distance from the top of these 2 points gets greater as the angle increases. So as they're close and as they spread apart. So we're going to use that knowledge to go ahead and write an inequality and solve and figure out all the possible solutions to a certain problem based on that hinge theorem. So let's take a look at our first example I have here. And I look at these two triangles and I see that they each have a set of congruent sides here and a set of congruent sides here. What's different about them is the third side of this triangle is 15, whereas the third side of this one's 8. That tells me something huge. That tells me that the distance from here to here is greater from here to here. Well, the only way that can happen is if the angle called 5x minus 9 is a greater or larger angle than 31 degrees. Because as this angle increases, this distance increases. Well, I can see that this distance is greater than this one, so it must have a larger angle. All right, well, I can solve that. I start looking at that and I say, well, 5x minus 9 is greater than 31. If I use my basic algebra here and I just do an add 9, 5x greater than 40, I can figure out really quickly that x is greater than 8, which means that for every number greater than 8, this is a true statement. I always want to test my work and make sure I'm correct, so I'm going to go ahead, I'm just going to pick a number that I know to be bigger than 8, throw it in there and see what I get. So I'll go with 10. 5 times 10 is 50. 50 minus 9 is 41. Is it a true statement that 41 is greater than 31? Yes. This can keep on happening as long as I pick numbers that are greater than 8. If I pick a number under that, it will not be true. So let's say I pick a number like 6. Well, 5 times 6 is 30. And 30 minus 9 is 21. Is 21, do you really believe this is 21 if this is 31? If I go in on appearance, I'd say absolutely not. And it can't be because of the fact that 15 is bigger than 8. It just doesn't make sense. So whenever you have doubts, always check your work. In fact, even if you don't have doubts, check your work. Because if you get your symbol backwards, it'll come up real quick that you'll be able to figure out that it's not the correct answer. All right, well, the same thing goes with the converse to this. Because before I told you that if this distance is greater than this one, then this is a bigger angle. Well, on the other side of that, if this angle is bigger than this angle, then this distance is greater than this distance. Which means that I should be able to write down the fact that 10x minus 8 is greater than 7x plus 4. Because 53 is bigger than 42, so that means that this distance is bigger than this distance. And the only reason I can do that is because they have this side congruent and this side congruent. So that hinge tells me that if this is 53, this distance has got to be greater than this distance. And that's that hinge theorem telling me that. Now, solving the problem is a little bit more difficult because I have variables on both sides, but I use the same rule every day, and that is always get rid of the smaller variable. I don't care which one's on the left and which one's on the right, just get rid of whatever variable is smaller, and in this case, it was the 7x. All right, well, if I add 8, I get 3x greater than 12 divided by 3 x is greater than 4. So for any number greater than 4, I will have a true statement. So again, like I said before, pick something easy and figure it out. So let me pick, I don't know, the next number after 4, 5. 10 times 5 is 50. 50 minus 8 would be 42. On the flip side, 7 times 5 is 35. 35 plus 4 is 39. Is 42 greater than 39? Yes, so it's true. If I picked a number less than 4, or the number 4, I would start getting false statements. All right, so now it takes a little bit of turn, and I'm sorry if I was going fast on that side. I just have to get to this tough problem because this problem is a little bit different than that one, and I'm going to show you why in a moment. All right, when I look at this drawing, I see that they have this side congruent for both. I see they share a side, which means I can make a comparison. They've got a set of congruent sides. They've got a second congruent side that they share here. I might even put a mark on it just to make sure I'm aware of it. And when I look at it, I see that 18 is greater than 13. So that means that this distance is greater than this distance. So that means that this 48 degrees has got to be greater than 4x plus 12. So when I write it down, I'm going to go ahead and start that way. 48 is greater than 4x plus 12. I know this. All right, well, if I minus this 12, I get 36 is greater than 4x. I divide by 4, and I get 9. But I don't like writing things like that. I don't write that as an algebra teacher. I don't write 9 is greater than x. I like to write it the other way. And that's that I put my variable first and say x is less than 9. All right, well that's good, and this is true. I know that the answer can definitely be any number less than the number 9, but there's a part where I have to say, wait a minute, I can't go too far below the number 9 because eventually what'll happen if I keep going lower and lower and lower, 8, 7, 6, 5, 0, and then all of a sudden I'm on the negative side of the number line. Will this keep being true? And the answer is no. There's a stopping point, and it's because of the fact we can't have a negative angle. This problem is only true to a certain degree. Okay, I can't keep going on forever. So what I got to do is I got to figure out what's the stopping point. I know, for example, I have to be able to say, where does this all stop? And here's where it stops. I know that the angle 4x plus 12 cannot be any number less than 0. I can't have this be a 0 angle because at 0 it's not an angle anymore. Okay, and if it's on the negative side, it's even less. So what I'm going to do is I'm going to say, well, 4x plus 12 has to be greater than 0 because we need it to be an actual angle. So what I'm going to write is I'm going to solve that, and I've got 4x, and when I divide by 4, I know that x has to be greater than negative 3. So I want to put this together and make a compound inequality. I'm going to say, hey, x is greater than negative 3, but less than 9. And this is called a compound inequality. And the only reason I had to do this was because I knew that there was a certain point that if I went too far below a certain number, I would end up running into a negative angle. I didn't have this over here because there's no negative angle that's going to happen. I'm just going to get bigger and bigger and bigger and bigger. But over here, I had to stop because this angle was, if you notice from the beginning, this angle was less than a number. Whereas over here, we were greater, which was okay. But on the left side, we have limitations. All right, the last thing I'm going to ask you guys to do today is I'm going to ask you to look at a drawing and make an assessment. Can you make one true statement about this picture? And I want you to look at it carefully, and I want you to see what things they have in common. We want to use the hinge theorem. We're looking for things that they have congruent so that we can make an assessment. So when I look at this picture, I see a set of 40s. This triangle has a 40, and this triangle has a 40, and then they have a shared side. That means that I can make some sort of assessment about this right here, this angle. I can make some sort of assessment because the 40 matches the 40 and they share a side. Well, here's my assessment. Since 32 is a smaller number than 38, I can say that, for example, angle ACB, this angle right here, has got to be less than this angle, DAC. And the reason I picked those two was, again, the 40, I found that hinge, they have the hinge here, and then this hinge is bigger. So it tells me that this is a bigger angle than this one. All right, well, that wraps this up. I hope this answers all your questions, and have a great day. Bye.